Hey guys, so in the last lecture, we have seen biogas plant. So as we have discussed in last lecture, that there are two types of biogas plant which we use widely in India. So the first one was the fixed dome type biogas plant, which we have discussed in our last lecture. So we will just quickly revise what we have seen in last lecture. So in this biogas plant, the slurry of cattle dung and water is mixed in the mixing tank, and after that it is moved to the inlet chamber, and it is then moved to the digester where the biogas is produced with the help of decomposition uh, of this slurry with the help of bacteria. So after decomposition, the biogas is generated, and the remaining slurry is moved toward the uh, exit or overflow tank, and that slurry is moved outside the overflow tank, and the biogas we can use for our cooking purpose. So the main disadvantage of this plant, as we have discussed in last lecture, was that it the construction requires skilled worker, and we are getting a variable gas pressure inside this. Okay, so today we'll see our next uh, biogas plant. It is floating uh, drum type biogas plant. So in this plant, so in this floating drum type biogas plant, the working is same as the fixed dome type biogas plant. That is, the biogas is produced as a result of anaerobic fermentation of biomass, okay, in presence of water. So anaerobic means in absence of oxygen. So the principle of both the biogas plant is the same. So we will see the construction of the floating biogas plant. So similarly, in floating biogas plant also, floating drum type biogas plant has first the mixing tank, which is present above the ground level, then the digester tank, so that is constructed below the ground, that is underground well like structure. So there's a difference in digester tank of from the fixed drum type uh, biogas plant, that here in floating biogas plant, uh, the digester tank is divided in two chambers by a partition wall in between, and it is two long cement pipes. It is inlet opening in the inlet chamber for introduction of slurry, and second, outlet pipe opening into the overflow tank for removal of the spent slurry. uh, Gas holder or drum, we can call it a drum, an inverted steel drum resting above the digester. And as in fixed dome type, the the dome was fixed. Here there is a steel drum which is resting above the digester, and the drum can move up and down, that is float over the digester. Therefore it is called floating or movable drum type biogas plant. And the gas holder has an outlet at the top which could be connected to the gas stove. Okay, so it is also called a gas holder because it contains gas. So in the overflow tank present above the ground level. Okay, so uh, this is similar the this is similar to the fixed dome, only there's a difference in digester tank. So we'll see the diagram. So as we can see here, Similarly, as in fixed dome tank, so there is first a mixing tank which is above the ground level. So this is the ground level, and above which there is a mixing tank. So here in mixing tank, the cow dung, the cow dung and bio waste is inserted, and also it is mixed with water. So it is mixed with water. So after uh, mixing, it is moved, it is flowed to the digester tank with the help of inlet pipe. Okay, so it is moved to the digester tank with the help of inlet pipe. So after the uh, the cow dung and the water which is mixed, it moves to the digester tank, and here in the digester tank, the decomposition of this slurry happens with the help of bacteria in anaerobic condition, that is in absence of oxygen, and due to which a gas is produced. And uh, so the gas is produced. So let's read the working point by point. So so the first point says that first the slurry, that is mixture of equal quantities of biomass or bio waste and water, is prepared in the mixing tank. So the objective of the mixing tank is to prepare the slurry, okay, by mixing the biomass and water. Then the second step is the slurry is fed into the inlet chamber of the digester through inlet pipe. Okay, so that we have seen that here biomass and water are mixed, and then it is moved with the help of inlet pipe. Then the plant is left unused for about 2 months, and introduction of slurry is stopped. So the plant is left for about 2 months, so and the slurry is not inserted. So during this period, an anaerobic fermentation, anaerobic means in absence of oxygen, decomposition of this biomass takes place, okay, and but in presence of water, so that produces biogas in the digester. So this will produce biogas in the digester in the free space where there is no space. So as this gas holder is moving, okay, so this gas holder is moving up and down, this can move till the space here, so till it is able to free, it can move from here till here. So this is the movement of the gas holder where it can move, minimum and maximum. So biogas being lighter rises up and start collecting in the gas holder. So as biogas is lighter, so it will move up, and start it will be start collecting in the gas holder. So uh, this this biogas moves up and will be start collected in the gas holder. So that before collecting, if the gas holder is empty, the gas holder would be in the downward position. So after it has started collecting the biogas, so uh, after it has uh, uh, collected the biogas, so it will move in upward direction, because after it has collected all the biogas, so the biogas will pressurize it and it will move in uh, above direction. So after the tank is filled, so the pressure will increase and the gas holder cannot move above a fixed limit. So it cannot move, the gas holder cannot move above this limit. So uh, what will happen after that, that so the gas holder cannot rise up beyond beyond a certain level. As more and more gas start collecting, more and more pressure is to be exerted on the slurry. So more pressure is exerted on the slurry after the gas holder has collected the gas. So what will happen, that this slurry will move from this chamber to the next chamber. uh, so it will move from one chamber of the digester tank to the next chamber of the digester tank due to the pressure created. So the spent slurry is now forced into the outlet chamber from top of the inlet chamber. So this slurry is now forced to move from the inlet chamber. So there are two chambers. There is here it is, this is inlet chamber and this is outlet chamber. So this will move from top of the uh, so this will move from the top of the digester tank. So this slurry will move from here to here. Okay, so next, so when the outlet chamber gets filled with the spent slurry, so when the outlet chamber is filled with the spent slurry, the excess is forced out with the help of outlet pipe. So once this is filled, so the excess can be filled out with the help of outlet pipe. So now why there is requirement of this partition wall. So this partition wall is required because the digestion process here required two types of bacteria, that is acid forming bacteria and other is methane forming bacteria. So both work in different conditions, so therefore their two chambers are given. So this will help both the bacteria to decompose in different conditions. So with the help of this partition wall, both bacteria will get a different condition for decomposing the slurry. So this is the main function of the partition wall. So after the spent slurry has been, that is decomposed, so it will further move out with the help of outlet pipe. So uh, the the outlet chamber gets filled with the spent slurry and its excess is moved with the help of outlet pipe uh, into the overflow tank. So this later used as a manure for plant. So it can be used as a manure for the this plant. So this can be used as a manure, okay, for the plants. So uh, after that, the gas valve of the gas outlet is opened to get the supply of the biogas. So after that we can use this gas valve. So there is a gas control valve, so which can be used for cooking purposes. So we can get exit from the gas from the gas holder. So once the production has begun, so once the production has begun, a continuous supply of gas can be ensured. So we do not have to wait every again and again. So once the production of the gas has begun, uh, so ensured by a regular removal of spent slurry and introduction of fresh slurry. So we should ensure that the spent slurry has been removed and the new fresh slurry has been introduced regularly. So, by introducing this new slurry and by removal of spent slurry, the continuous production of the biogas can be obtained. So, now we will see what are the disadvantages of this floating gas holder type biogas plant. So first disadvantage is that it is expensive. Okay, so this biogas plant is a little bit expensive than fixed type biogas plant. So second is steel drum may rust. So second is a disadvantage that from the fixed dome type biogas plant, that in fixed dome type biogas plant no maintenance is required, but here in floating biogas plant the steel drum may rust. So to protect it from rusting, after a certain period of maybe 1 year, the uh, this drum needs to be painted to remove the rust, or it has to be maintained. So regular maintenance is required in this steel type biogas plant. So these are the main disadvantage of this floating gas holder type biogas plant. Now advantages. So first advantage is high calorific value. Okay, so the calorific value of this biogas is high compared to that of fixed drum type. Second is clean fuel. So there is no wastage, and there is no smoke or toxic is produced here. So the biogas produced here is clean fuel, and there is no residue. So there is nothing which is left out. The slurry which is coming at the exit can be used as a manure, so it is not a wastage. So there is no residue produced, there is no smoke produced. So as everything is inside uh, uh, underground, so there is no leakage or smoke which is produced, so which can harm the environment. Only the gas which is produced, we can use it directly as a cooking fuel. So non-polluting, so there is no extra gases which are produced, so which has to be released in atmosphere, and which may create some pollution. Economical, so this is basically economical on the basis of the gas which we are getting, and the amount which we have spent on this plant. So basically it will be economical in nature. Then can be supplied through pipelines. So this gas can be supplied or with the help of pipeline in 100 meter of range. Okay, so it cannot be supplied till further distance, but in 100 meters of range. Burns readily, has a convenient ignition temperature. So this gas can be burned readily as it is exited from the plant. So it has, because it has higher calorific value. So this are the advantages of biogas as a fuel. So now let's compare both the biogas, that is fixed dome type biogas plant, and floating dome type biogas plant. So as we can see that here, in fixed dome type biogas plant and floating dome biogas plant, so there is uh, mixing tank similar in both the biogas plant. Then there is an overflow tank similarly in both the biogas plant. Okay, so the overflow tank in fixed dome type can be constructed above the ground also. So the mixing and overflow tank is the same, only the difference is here in the digester tank. So here in digester tank there is a fixed dome type shape, while in floating biogas plant, here it is a steel drum which is constructed and which is allowed to float up and down. So that is the difference. And another difference is that in digester, uh, in floating dome type biogas plant, there is a partition wall in between them. Okay, so here there is no there is no partition wall in fixed dome biogas plant. So this is the difference. And in fixed dome type biogas plant, so the construction is such that, so there is no pipe required, pipe flow is not required, just it is constructed in such a way with the help of bricks that the slurry can flow easily with the help of passage. While in floating dome biogas plant, the two pipes are required, inlet pipe and outlet pipe. Okay, uh, so these are the main differences in both fixed dome and floating dome type biogas plant. Okay, so both of them have advantages and disadvantages, and both are widely used in India. So I hope that you have got a clear understanding of both of the biogas plant, and uh, what is the difference between them, and which is more suitable to according to your preference. So hope to see you in your next lecture.